Okay, everyone, we're going to go ahead and get started, get kicked off here. This is Liz Dinsmore with LEC Incorporated, and I wanted to welcome you today to our Cloud-Based Utility Solutions 101 webinar in partnership with U.S. Cellular. A few quick housekeeping items before we get started with today's webinar. Please, again, just a reminder, if you would remember to mute your device's microphone to try and avoid any extraneous feedback during our webinar today. And also, there will be a Q&A session at the end of the webinar, or you may use your chat feature as well to send questions during the webinar, or you can also hold those until the Q&A session at the end. This webinar is being recorded, and we will be sending out a on-demand recording of this webinar via email to all the participants after we finish up today. So with that, I'm going to introduce our speakers for today. First of all, we have Justin Hogue, VP of Business Development with LEC, and also Bill Berkowitz, Director of Sales, Data and Software Solutions for U.S. Cellular. So I'm going to throw it over to Justin to get us started.
Thanks, Liz. So I'll give you guys a bit of background here quick on LEC. So I'm proud to tell you guys that we are officially into our 30th year in the industrial controls, automation, and engineering industry.
Is now joining.
Over that time, we've built a talented staff of experienced automation and IoT engineering professionals to include a number of engineering disciplines. We've also established national sales, systems integration, and support channels, which allow us to grow and scale while providing the level of customer service and support that we expect to deliver. As a result, we've developed a very unique set of industry skills that allows us to meet the IoT needs of our clients across these many industrial verticals to the extent that our team has been recognized globally several times over the past year or so as an award-winning IoT platform provider and developer. With that, Bill, would you like to give some background on U.S. Cellular and maybe the relationship between our companies?
Absolutely, and thank you, Justin. U.S. Cellular is the fifth largest wireless carrier in the United States and has decades of experience providing wireless solutions to businesses as well as in the public sector. Our teams of business sales executives are dedicated resources to our clients in 22 states. And additionally, my team specifically at U.S. Cellular provides solutions architects who are well-versed in deploying machine-to-machine or IoT solutions, as well as wireless data solutions in general. We help organizations of all sizes deploy data solutions to provide real-time visibility to their remote assets. U.S. Cellular and LEC have enjoyed a partnership together for several years. U.S. Cellular is extremely competitive in the wireless ecosystem, and we have a fiercely loyal customer base because we've built our reputation on providing an exceptional experience, both on our network and when working directly with our people. We've been very happy to find a partner in LEC who shares our commitment to that high level of service. As we start to dig into the details of these solutions today, there are a couple important items I'd like to point out. The first is that we can implement private networks with our government and utility clients. This kind of secure connection between our network and yours ensures that your data never touches the public internet. Utilities are considered critical infrastructure, and the private network ensures a higher level of security. I'll cover on that in a little bit more detail on a later slide. Secondly, U.S. Cellular owns and operates its own network, and we have a robust plan for continuity of operations. We create redundant connections for the private network and have geographic redundancy for our data centers. And the radio network itself is extremely resilient. In the event of natural disasters, we employ solutions like battery backup and remote generators for power. And we even have mobile assets that we can deploy in the event that a tower is down completely, such as when a hurricane or a tornado strikes. Additionally, we provide prioritization and preemption of data traffic, which means that in times of emergency, our first responders and critical infrastructure clients get priority access to the network. All of this ensures the best possible experience for U.S. Cellular's business and government clients. So without further ado, to get into more detail around the solutions offered by U.S. Cellular and LEC, I'm going to turn it back over to Justin.
Thanks, Bill. So let the fun begin, right? Okay, so when we discuss the key points related to IoT and applications such as water, wastewater, for example, we have to first talk about the differences between traditional and cloud-based SCADA architectures. The differences tend to be related more to how we communicate, how we deploy, and how the visual data is accessed, both for actual viewing and any remote intervention or control. For example, many cloud-based IoT solutions utilize cellular communication that works in a way that's highly scalable in terms of deployment, where traditional systems tend to utilize licensed or non-licensed RF networks that require actual tower infrastructure, heavier configuration, and more ongoing maintenance. Another example, software and servers, where traditional architecture is used, the end user is responsible for hosting and maintaining the software application within their own facility. Obviously, this places the burden of server and application management on the end user, and at the same time limits the ability to remotely access the application for monitoring and, again, remote intervention via mobile devices, PCs, or other devices while away from the facility. So what we have here is where marketing and engineering come together. We included this chart listing some of the differences based on traditional architectures versus cloud-based architectures. We're not going to cover every point. I'm sorry to disappoint, but we're not going to cover every point listed here. However, this chart will be a part of the version of the presentation deck that will be distributed after the webinar. So I want to point to some key things here, and those would be where cloud-based systems are concerned. There's far less upfront investment than with traditional systems, where significant upfront capital expenses are pretty much the norm. Many cloud-based systems include communication with a great deal of redundancy that's there by default, where traditional systems based on RF network communications are typically void of network redundancy. Then there is response to emergency or natural disaster situations. With self-managed RF networks, you're on your own, as opposed to cellular, where you have the advantage of being able to leverage the DR plans of any associated carriers. Moving on to cloud-based applications and where they're most applicable. Cloud-based applications, first point I'd like to make here is that cloud-based applications are not intended to replace the HMI systems located in plant control rooms. A common misconception that we encounter from time to time. Rather, they can be used in parallel to enhance efficiency, awareness, and provide the ability to monitor status anywhere and anytime. Some good examples of where cloud-based systems are most applicable would be in oil and gas drilling production, transportation, custody transfer, water, wastewater pump station monitoring, drinking water, pumping, storage and distribution systems, OEM machine monitoring, agriculture, and again, the manufacturing process and automation systems associated with the plant floor, where IoT solutions can be used in parallel to traditional control room SCADA. In all these areas, IoT can be used as a gateway to more granular and longer-term data analytics and more efficient asset deployment and management. Data security. basically three levels to discuss here: physical, network, and application. So starting with the physical level, security starts here. It's amazing, but often security gets overlooked at this level, and it's probably the most obvious. I mean, we lock our cars, we lock our homes when we leave, so it stands to reason that we should keep our equipment behind lock and key, right, to begin with, as an initial step. So, beyond that, do you have open communication ports, Ethernet, USB, serial, and so forth? How do we best utilize native features in our devices, such as firewalls and whitelisting, blacklisting, filtering? Do you have an open local wireless network? Wireless Ethernet, LoRa, 900 megahertz. These are some examples of commonly used protocols for sensor networks. Are they secure? Are they locked down? And again, control of physical device access. It's lock and key. The first step, simple. The network level, the basic steps to take would involve limiting network visibility of all devices. That is limiting network ingress and egress together. Separating subnets for different types of traffic and levels of access. What types of scanning, logging, and other measures are appropriate? The key here is to define an appropriate security program based on the application. At the application level, how will the application be accessed and what can the user do with it? Evaluate the implications of allowing remote intervention and operation. We open ourselves up potentially when we allow remote control of a system. So it's important to evaluate to what extent that is allowed or applicable. How do we handle denial of service or brute force attack? How do we mitigate these? What level of data encryption should be utilized? So to help answer or at least provide a foundation for developing answers to these questions, we're going to put some additional emphasis on the connectivity, the network security level. This is an area where many struggle when defining solution architecture. Specifically, we'll discuss, quote, good cellular network architecture and, quote, not so good cellular network architecture in the context of IoT applications. So to begin with, we'll talk about public network, internet-facing connectivity. In the very beginning, this is how we here at LEC utilize cellular, but we quickly realized how incredibly vulnerable our assets were, thankfully through experimentation and not as a result of unplanned or unexpected malicious activity. Basically, the internet is wide open, and any device connected to it with a fixed IP or static IP address, those devices can be seen by anyone else in the world who has a PC, a tablet, or a smartphone that's also connected to the internet. So the security of any device connected in this manner is in fact reduced to the features native to the device itself: firewalls, filtering, other software features, and sooner or later, someone's going to find it. In our test case, it was less than 24 hours before we had to start blocking attempts to execute brute force attacks. So this is scary stuff when you consider the types of things we connect every day. I guess I would say that an underlying key point here is that ultimately the success of an IoT project or solution depends largely on the ability to communicate data. So how can we efficiently minimize these vulnerabilities while at the same time enhancing our ability to deploy efficiently? We'll go back to Bill for some insights on how we can do that.
Thanks, Justin. And I think I'll start with an example we're probably all familiar with. When you activate your smartphone on a cellular network, you're assigned a private IP address. Your device is not visible to every single person on the internet, and a bad actor is not able to easily launch attacks directed specifically at your device. But when you deploy a device to be used for a SCADA system, for example, to monitor and control a well or a lift station, you need to be able to reach out and find that device. That's the whole point of the solution. And I've gotten many requests from clients to assign public static IP addresses. There's a perception out there, I think, that it's just easier. A client can easily find their device over the internet and communicate with it, which is true. Unfortunately, it is also a lot easier for anyone to find that device, which is what Justin was just describing. And there are a lot of bad actors out there looking for opportunities like this to exploit. Even when you secure your device and the assets behind it, with a public IP address, you can experience problems. In one case, we had a client whose device was being pinged thousands of times a day. And even if there's not a security breach, activity like that can result in performance issues and degradation, and can possibly result in higher charges for the sheer amount of cellular data that's being used. The solution is to utilize private static IP addressing. U.S. Cellular's teams of solutions architects work directly with our clients to implement private networks, ensuring that your data doesn't touch the public internet and your devices are not visible to malicious users. Our process puts you in direct contact with our core engineering team to ensure that the implementation meets the specific configuration requirements for your project. And you're able to monitor and control those cellular devices similar to how you view other devices on your local area network. It might be a little bit of an oversimplification, but think of it as seeing these cellular devices as an extension of your LAN. The result is that there's a lot less time spent and resources spent by having a carrier-grade solution in place to provide secure visibility to your assets. I know we may have questions, and I'm sure people will want to know how to get in contact to discuss their projects. So, Justin, I'm going to turn it back over to you.
Yeah. Thanks, Bill. So what do we need to do to get started exploring IoT and understanding what we need in terms of security and features, functionality, performance? This is important. You need to make sure that you have the correct IoT partner, one who can help you ask the right questions, one who can help you develop sensible requirements and provide solutions to meet the needs at all levels in a secure, reliable, scalable, and efficient manner. LEC and U.S. Cellular are here and available as a team to help you implement IoT solutions in a safe, secure, and reliable manner. So we've got a few pieces of information here on this slide. Our team is happy to schedule a demo. If you want to request a demo for any of the solutions that we provide between U.S. Cellular and LEC, we're happy to do that. You can contact us at the link on the slide here. We've got information on all of the above available for download. And you can also feel free to contact us via email at the address listed here, and we'll be happy to speak with you or schedule a demo or provide information that you need. I think at this point we're ready to open the floor up for Q&A. So we can go ahead, Liz, and open the floor for Q&A.
Okay, great. So if anyone has a question that you would like to ask, you could just unmute your
+1 81683266343
is now exiting.
Any questions at all? Doesn't look like we have any questions. Okay. Well, with that, we will go ahead and wrap it up. Like we said, feel free to contact us if you do think of anything that comes to mind. And we appreciate everyone joining us today, taking the time to join the webinar.
Unknown participant is now joining.
And we hope you have a great Tuesday. Thanks so much, everyone.
Thank you, guys.
Thank you, everyone.
Multiple people are now exiting.